The purpose of our PSpice program is to predict what is going to happen if you would build a circuit in the real world if you use components from which you have drawn in your schematic circuit. Now there are vendors. They're like factories and technicians, scientists, chemists. Let's say they have discovered and learned how to make a new component. Let's say, I don't know what this component is, but it has 7 connections to the outside world. But if you look inside it, there's a lot more connections, and there are all kinds of models for the components inside this part. More models here. So you need scientists, chemists, technicians to make test setups, and you need salespeople which can borrow or buy sophisticated professional measurement equipment to extract all kinds of those model parameters from test measuring. And then you need people who know how to use computers and how to use Spice and to make those models. You need media people which can put those libraries on a site from their vendor. They make a website and provide those library files, which is this. So just let's pretend we are a vendor of a new Zener diode, and people have measured all kinds in test setups and wrote down those parameters, and other peoples which work with computers have made those library file for this component. So let's pretend we are a vendor, and we have extracted all kinds of model parameters, and we want to sell a new kind of Zener diode. So there must be somebody who wants to make a library where this new part has all those parameters in a library. This is a library. Okay, we're going to make a workspace first in the C hard drive, and it's our new Zener diode. And we need a schematic to put all those components, those parts in it. To make a sub-circuit which has only those connections to the outside world. So we're going to save it as and uh, we don't have all those components inside it because we we are only students, so we just keep it simple, and it looks like this. But we need connections to the outside world, which are bubbles. And scientists have discovered that we need to add our library for this diode. So let's search for it. It's here. Add library. Okay. Scientists have discovered that they have done measurements in the laboratorium, and there's all those model parameters. And it happens, it is a 10-volt Sire diode. Sorry. So this is just a fake Zener diode. And this is the cathode. This is the anode. Normally you would have another diode here. So you can see this is the anode and this is the cathode. It will be just a normal diode. But if you have a Zener diode, you reverse the connection. You put the minus here and the plus here. what we what 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 those vendors do when they make subcircuit, they use this command, create subcircuit. It's really just a circuit, but without a reference zero voltage node. So let's set up a simulation. You simulate it. It says simulation complete. Now what we really want to do is, oh, not here. What we really want to do is make a voltage source and see what is going to happen. A changing voltage source and see what is going to happen at the node. So let's set up a transient analysis. Put a voltage marker. Simulate. And it's done. It's just 5 volt. So normally when you are going to simulate to see how a circuit works when you build it, you need to use a zero reference node. But we are not going to use a circuit file. In the old days, you had to type in all those components, and then here, those components, and then you had to type in the nodes in the correct order. So if you have a diode, then you first have the anode and then the cathode. This is not anode because I have changed this node name, but if you have a diode, normally this is the anode and this is the cathode. You have a voltage source. First you have the plus and then the minus node. So you have the plus node. Where is it? The plus node and then the minus node, which is 0. So PSpice expects to have all outside connections for each part in a certain sequence. But we don't want to make a circuit to simulate this. We don't want to have this this outside world connection always to the 0. So because we are going to make a sub-circuit from it, not a normal circuit. subcircuit, so let's make it. Let's take a look inside our subcircuit. Here it is. Here's the subcircuit. So, we just created a subcircuit. Just like all those professional vendors made a subcircuit, but they have added much more components, and they have changed all those model parameters from measurements. So we want our subcircuit in a library, which we then can use as a part, just like in a real library with only a few connections to the outside world and all kinds of parts inside. So you have just those outside world connections, and those parts are inside. So you go to your subcircuit, open it, select the text and copy it, make a new file, paste it, we need our outside world connections in the right order, then save it as our own library. Select this, all files. You need to put lib behind it to say that this is a model library. So the only thing we did is just changed the subcircuit file to a library file. Show it again. So this is the subcircuit file, and this is the library file. It's just the same, but I removed those blank lines. Okay. choose our library file, copy it, and put it in our userlib program files ORCAD pSpice userlib folder. You can see it here. This is a standard userlib folder. Then we go make a symbol from this using invoke symbol editor. Use symbol wizard from library. Our library. And we want our symbols in a standard library, because you cannot make additional symbol libraries in the student version. So here's our new Zener diode. Choose a Zener diode symbol. This is our description. Close it. Close this. Now I want to now we want to use our new Zener diode in a real circuit file with a zero reference ground node, this one, and we want a voltage source, a sinusoid voltage source. We need a resistor, and our new Zener diode. Let's connect those things. give it a name for the node. Now this voltage source, we give it a offset. This thing is 10 volts, so we give the offset of let's say 5 volt. And then it must go above the offset of 5 volt, above 10 volt, so we need at least 5 volt amplitude. It just increases a bit to 10 volt. So it's going from 5 to 15 and 5 to -5. Then we need a frequency. I just like to have a frequency of 1 kilohertz, and that's okay. Take some markers. Set up a transient analysis. This is 1 kilohertz, so 1 sinus is 1 milliseconds. So let's take a look at 3 sinuses, which is 3 milliseconds. Now, simulate this. Did I include the files? Let's see, I don't know. Maybe we need to include eval. To it's undefined, this model, so we need to include our library, browse to it, eval lib. Eval.lib is necessary because it describes those diodes which we made inside this. So now it must work. Okay, so we have our input voltage here. It's going from 5 volt to 15, so 10 volts extra, and 5 volt to -5. Just this is the offset of 5 volt. The offset of 5 volt, and then it's going to swing 10 volts around this 5 volt. 10 volts difference. And then our Zener diode is going to make 10 volts or almost not conducting. So this is exactly what we wanted. So now we pretend that we are a vendor, and we have pretended we made a library with subcircuits and made it into a symbol for this Zener diodes, and we know there is those other parts inside it, like those these diodes and this DC voltage source. So that's what I wanted to explain about why vendors make libraries, because customers want to experiment with parts which mimic how they would perform if you would really build it, and so customers can decide if this is a good part to buy or not.